Dear faithful YouTube viewers, welcome to Nate's garage and place where he keeps his 3D printer that he built 2 years ago and hasn't touched since. I haven't been spending a lot of time with the 3D printer in the last 2 years because I was having problems getting decent prints out of it. For instance, this little piece here, which was one of my first attempts at a Z-axis brace, you can see all the holes. Just a terrible print. This is ABS. But when I first made the thing, I did make this thing, and it printed out beautifully. I mean, it's, there's no gaps anywhere. It's whatever. I haven't killed anybody with it yet. Just a little rundown on the problems I've been having. For instance, on this little Nate thing that I've made here, you can kind of see in the A there the separation in the perimeter prints of the surface of the A there. Things like this where the layers were all very far apart. Things like this where just absolutely nothing was going right. Things like this. This is actually PLA, but this is supposed to be a cylinder of the same diameter all the way around, and you can see there's a bunch of warping there at the bottom of the print. Not sure what happened to this. This is a Z-axis proximity sensor adjustment thing that can slide up and down to make it easier to adjust your Z-axis on this particular printer with a proximity sensor on it. And it's supposed to slide in and out, but I can't even get it apart anymore. It's jammed in there pretty good. It turns out I wasn't using the software correctly. My software of choice was called Slicer. It gives you a bunch of parameters that you can set for width of the print, stripes, and this and that, and layer height, and blah, 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 blah. There's a whole bunch of settings in there. I actually misinterpreted some of the settings, and therefore we're getting worse prints out of it rather than better prints out of it. Well, things have been changing a little bit around here. This is actually still a print with the Slicer software, but after I realized that I was doing things wrong in the settings. This is made out of PLA. You can see there are still problems with the solidity, I guess you could call it, of the surface. There's lots of holes and stuff in there and some questionable stuff going on. However, things printed out well enough for me to be able to, I printed these tires out separately, and these hubs that actually keep the tires in place separately, and everything fit over what they were supposed to fit over, and the hubs snapped into place to keep the tires in place. And, after I separated a bunch of bridging material out, I have, a suspension on the back of this here four-wheel drive truck. Yeehaw! But then, let's talk about homing, shall we? When I bought this printer, I purposely bought the model that had the automatic bed leveling. So there's a proximity sensor back here, and it senses the closeness to the bed. The other ways that printers will do that is actually have another little micro switch down here at the bottom so that the bottom of this carriage touches the micro switch when you're homed. You're able to adjust that up and down to get the print nozzle at the correct height for the bed. Being that I got the model, this is the HIC Technologies 3D P11 model. The reason I got this particular one is because it had the automatic bed leveling feature. I didn't want to have to mess around with actually manually leveling the bed, so I got the stuff that had the built-in functionality of sampling multiple places on the bed before it printed, and then integrating that into the actual print code. So it would start printing, and these little Z-axis motors here you'd see adjusting as the print came across here. Doing one layer, you'd see the print, the Z-axis adjusting to make up for the unlevel bed. Well, one of the best things I did for the quality of my prints, besides figuring out that I was misunderstanding software settings, was to manually level the bed. I actually updated the firmware in my control here, simply to get the better homing that is available now. With the mesh homing, you can actually specify as many points as you want on the board, and it will actually go through and sample all those every time the print starts. When I flashed it with newer firmware, it actually came in with a simpler set of homing. It only sampled one spot on the board before it started printing. I got a little tired of dicking around with firmware and stuff, and I decided to just manually level the bed, and that turns out to be the best thing I ever did. The way it was, even with the self-leveling routine, I would, get the homing sensor set just so that it was perfect over here and seemingly perfect. But when it started printing out, over here, maybe I'd start basically scraping the end of the nozzle onto the bed on the first layer and cutting off all plastic flow so I wouldn't get anything over here. But then over here, it would be so far off that it was actually just leaving a trail of hanging plastic on this side. It was pretty bad. So what I did was manually leveled the bed. We'll get into that. So that's what I started getting to print out when I figured out that my software settings were wrong. That was still a slicer. Now we are printing some beautiful stuff out of here, and this is pretty much because I changed softwares. I went back to Kira, partly because it's what I needed to update the firmware. I decided to just try it anyway, and I started getting some really nice prints. This part here, for instance, obviously two different colors of plastic, both ABS. It's a filament roll holder that is adjustable width. So depending on the roll of filament and whether it fits or not on this, this particular roll of filament, I can adjust this with this screw. And this side over here slides in and out to make it wider or narrower. So you can fit your narrow ass on there, or you can fit your wide ass on there. So undo it a little bit, still not quite there. I'll just unscrew it some more, and voila, it just slips right into the rollers. I need to do a little bit of work on those rollers yet to get them to actually grip the rim of this, but in any case, it's freaking beautiful. Look at this thing. I got a glossy finish and everything, and part of that's also because of Kapton tape. Kapton with a K, K-A-P-T-O-N. It's a plastic type of tape that is heat resistant and more or less gives you these nice glossy prints. You can do that with glass too, but I didn't really want to get more material on my bed that has trouble heating up in the first place in some reasonable amount of time. So yeah, check it, baby. I'm printing stuff out that I have screw threads in that thread into each other without me having to rework anything on the print. It gets done printing, I take it off the print bed, I jam it in there, and it threads right on through. And this, for instance, this slide right here, this side of the filament roll holder is sliding on this part of the filament roll holder. I had jammed it on there, worked it back and forth a couple of times, and it's basically, it's nice and tight, but it also slides whenever I screw the actual thing on there. These little axles for the filament roll holder, those hexagonal axles, obviously a different type, different color of plastic, and printed at a different time, and they fit right into the part they're supposed to fit into. Now, some of that is because of the design of these parts. I am not a mechanical engineer. I know a lot about mechanical engineering type stuff, but things like tolerances escape me sometimes, or I forget about them. I'm learning. But basically, you can't have a half-inch hole and expect a half-inch part to fit exactly in the half-inch hole. You have to have a slightly larger hole for that half-inch part to fit into, because tolerances, especially with a 3D printer that you bought off of eBay and built yourself. How do you level a bed on a 3D printer? Well, I'm sure there's other videos out there on how to do it. I don't know that I watched any of them. This is how I did it. At the very top of the thing here, with this rail up here, first of all, when I built the frame, I made sure it was square. And so that is my reference point, is the frame. Rail across the top here, and the frame on the side and whatever. So step one, make sure your frame is square. The next step, you don't just want the bed level, you want the carriage axis level, so the x-axis. You want that level as well, so that when the carriage moves back and forth, it's exactly the same distance above the bed over here as it is over here. The way you can do that is to, again, use your top bar and use that to measure to the rail, the top rail of the carriage. So you measure from here to the top. Again, use some fine measurement like millimeters or, fractions of an inch. And then you measure over here. The way you adjust that is to move one of these z-axis screws. Make sure you hold on to the other one while you move this, because even when the thing's turned off, they tend to turn together. Unscrew or screw to make it go higher or lower on that side only until both sides match up. You'll notice that I have marks on my z-axis screws, and one on this side also. And that is so that I know that when these are both facing forward, then I know that my carriage is level. Because when you're powered down or when you're done printing, the processor lets go of the stepper motors and they kind of free float, and if you put any pressure on stuff elsewhere, they can move. See, nothing's powered up, and whatever jiggling around might happen. My marks let me at least make sure that the carriage is parallel to the top rail before I set up any homing routines. And once the steppers are engaged, those stay in sync with each other. Now that I know that the carriage is parallel with the frame, I measured from the bottom rail of the carriage to the bed. And I think for that matter, I probably even measured from the bed to the top rail. What I did was put the beds to different places with the nozzle at a certain height that I could slip a piece of paper under just so, and I moved the carriage and the bed around to different places on the bed and made sure that it was the same all around. And I adjusted the height at each of the four corners until everything was perfect. That has allowed me to do a bunch more better prints. Much more better prints. Yeah, better prints. Let's talk about getting stuff to stick to the bed, shall we? So one example is this filament roll holder, where you can see the chowdered up part here. That side was bedside down when it printed out, and that part lifted during the print, and that's why it looks like trash right there. This is ABS, which is the hardest stuff on the planet to get to stick to the bed, it seems like, so I've been through several iterations of how I get things to stick. What I had been using was just the bed and then ABS juice. And all ABS juice is ABS plastic dissolved in acetone. And so I've got two different colors depending on what I'm printing. I don't want a layer of black schmoo on the bottom of my light colored prints and vice versa. That is what you see, this cloudy substance here on the surface of this print. Again, that was bedside down, and that cloudy junk there is the ABS juice that came up with it. So how does ABS juice work? Like I said, you dissolve ABS plastic in acetone, and then you smear that on the bed, and the acetone evaporates, and it leaves you with ABS plastic. So ABS plastic sticks to ABS plastic pretty well, it turns out, especially when you have the bed real hot. Obviously, I was using the juice, but I still had problems with it sticking. It's possible that this was back in the day when I didn't have my homing all the way down correct, so maybe that part of the bed was so unlevel that it didn't stick because it wasn't ever on the bed. Don't know. What I have also resorted to is Kapton tape. And what I found was a package of 10 8-inch by 8-inch sheets, or 204mm by 204mm for you metric types. and that's one of them on here on the bed right now. It's just a plastic. It's a heat-resistant plastic. It won't succumb to the rigors of hot plastic being melted to it or whatever. You can leave this tape on there for several prints, and then you can peel it off of there and stick another sheet back on. You can get rolls of this stuff. You can get sheets like this. The sheets are a little bit a pain in the butt to put on because this stuff's really sticky. It's kind of like window tint. It's really thin, and so you have to peel it off and then put it down and keep the bubbles out of it. When I printed this part, this filament roller, I didn't put any ABS juice down, and most of these parts stuck just fine. That side right there, that right there, this whole big piece here was one big piece printed like that, all the way up this high. The one problem with this print that I found was here towards the what would have been the top of the print. You can see this stepping of the last many layers. What I surmise may have happened is that since this was sitting up this way, that perhaps it dislodged from the bed at some point, and I just got lucky that it didn't go completely off the tracks. I'm not sure what happened here. I'm not sure because when I came back to this, I let it run overnight, and when I came back to it after it was done, the bed was already cooled off, and the parts more or less just came right off the bed. There was no prying. It was pretty much that they were just ready to go. Boom, they were gone. So that's why these are so clean, is because there was no ABS juice on the bed. It was just Kapton tape. Nice glassy smooth surface there. So the black parts I did use ABS juice. That's what you see on the thing here, and I had to knock these off of this thing pretty well. They didn't come off completely willingly, so just the addition of the ABS juice to the Kapton tape made parts stick very well. And that's these black parts here. You see, nice glossy. I'm sure there's still ABS juice on there, but since it was a nice glossy finish to start with, it was they printed out very nicely. So that's how I've been getting things to stick to the bed when I print ABS. PLA, on the other hand, I have not had any problems getting to stick to the bed when I use good old blue masking tape. And for that matter, you can see on the bottom of my print here of the truck, I never did clean it off. This is masking tape. That is the non-sticky side of masking tape that's stuck to the bottom of this print. Because you'll put strips of this masking tape down, sticky side down, to stick to the bed, obviously, and then you print this on top of it, and I have had zero issues getting the PLA plastic to stick to blue tape. So I haven't actually tried printing anything PLA just on the Kapton tape yet, which is probably what I'll do, to see if I can get rid of the extra step of having to clean off the prints of the extra masking tape.